Today we're covering every car cooling system type and what makes each one different. From the basic principles of heat transfer to the complex systems used in modern cars, we'll explore it all. So let's start with the basics. A car cooling system is designed to remove heat from the engine and transfer it to the atmosphere. This is crucial because engines produce a lot of heat, and if that heat isn't removed, it can cause damage to the engine and other components. The first type of cooling system we'll discuss is air-cooled. Air-cooled systems use a combination of airflow and metal fins to dissipate heat from the engine. This type of system is commonly used in older cars and motorcycles. The advantages of air-cooled systems are that they're simple, lightweight, and inexpensive. However, they're not as effective as liquid-cooled systems, and they can be noisy. The next type of cooling system is liquid-cooled. Liquid-cooled systems use a combination of a coolant, a water pump, and a radiator to dissipate heat from the engine. This type of system is commonly used in most modern cars. The advantages of liquid-cooled systems are that they're more effective than air-cooled systems, and they're quieter. However, they're more complex, heavier, and more expensive. Another type of cooling system is evaporative cooling. Evaporative cooling systems use a combination of a coolant, a water pump, and a radiator, as well as a fan and a condenser coil to dissipate heat from the engine. This type of system is commonly used in some hybrid and electric cars. The advantages of evaporative cooling systems are that they're more efficient than traditional liquid-cooled systems, and they're quieter. However, they're more complex and more expensive. Now let's talk about the components of a car cooling system. The first component is the coolant. The coolant is a liquid that's designed to absorb heat from the engine and transfer it to the radiator. The most common type of coolant is a mixture of water and ethylene glycol. The next component is the water pump. The water pump is responsible for circulating the coolant through the system. The next component is the radiator. The radiator is responsible for dissipating heat from the coolant to the atmosphere. The radiator is typically made of a combination of metal and plastic, and it's designed to maximize surface area to improve heat transfer. The next component is the thermostat. The thermostat is responsible for regulating the temperature of the coolant. It does this by opening and closing a valve to allow or block the flow of coolant to the radiator. The next component is the fan. The fan is responsible for improving airflow through the radiator to improve heat transfer. The fan is typically electric, and it's controlled by a thermostat or a computer. Now let's talk about some examples of cars that use each type of cooling system. The Volkswagen Beetle is a classic example of a car that uses an air-cooled system. The Beetle's engine is located in the rear of the car, and it uses a combination of airflow and metal fins to dissipate heat. The Toyota Corolla is a classic example of a car that uses a liquid-cooled system. The Corolla's engine is located in the front of the car, and it uses a combination of a coolant, a water pump, and a radiator to dissipate heat. The Tesla Model S is a classic example of a car that uses an evaporative cooling system. The Model S's electric motor is located in the rear of the car, and it uses a combination of a coolant, a water pump, and a radiator, as well as a fan and a condenser coil to dissipate heat. The Porsche 911 is a classic example of a car that uses a combination of air-cooled and liquid-cooled systems. The 911's engine is located in the rear of the car, and it uses a combination of airflow and metal fins, as well as a coolant, a water pump, and a radiator to dissipate heat. Now let's talk about some common problems that can occur with car cooling systems. One common problem is a leak in the system. This can cause the coolant to escape, and it can lead to overheating and engine damage. Another common problem is a faulty thermostat. This can cause the engine to overheat or run too cool, and it can lead to engine damage. Another common problem is a faulty water pump. This can cause the coolant to not circulate properly, and it can lead to overheating and engine damage. To prevent these problems, it's essential to regularly check the cooling system for leaks and to replace the coolant and other components as needed. It's also essential to monitor the temperature of the engine and to address any issues promptly. By following these tips, you can help to ensure that your car's cooling system is working properly, and you can help to prevent overheating and engine damage. In conclusion, car cooling systems are a crucial part of any vehicle, and they play a vital role in keeping your engine running smoothly. By understanding the different types of cooling systems and how they work, you can help to ensure that your car is running properly, and you can help to prevent overheating and engine damage. So whether you're a seasoned car enthusiast or just starting to learn about cars, this video has provided you with a comprehensive overview of car cooling systems and how they work. Now let's summarize the key points. We've discussed the different types of car cooling systems, including air-cooled, liquid-cooled, and evaporative cooling. We've also discussed the components of a car cooling system, including the coolant, water pump, radiator, thermostat, and fan. We've provided examples of cars that use each type of cooling system, and we've discussed some common problems that can occur with car cooling systems. By following the tips outlined in this video, you can help to ensure that your car's cooling system is working properly, and you can help to prevent overheating and engine damage. So, which type of cooling system is best? The answer depends on the specific application and the requirements of the vehicle. Air-cooled systems are simple and inexpensive, but they're not as effective as liquid-cooled systems. Liquid-cooled systems are more effective, but they're more complex and expensive. Evaporative cooling systems are more efficient, but they're more complex and expensive. Ultimately, the choice of cooling system depends on the specific needs of the vehicle and the preferences of the driver. In the future, we can expect to see more advanced cooling systems that are designed to improve efficiency and reduce emissions. These systems may include advanced materials, such as nanomaterials and metamaterials, and they may include advanced technologies, such as thermoelectric cooling and magnetic cooling. By investing in research and development, we can help to create more efficient and effective cooling systems that will help to reduce emissions and improve the performance of vehicles. In the meantime, it's essential to regularly maintain your car's cooling system to ensure that it's working properly. This includes checking the coolant level, checking for leaks, and replacing the coolant and other components as needed. By following these tips, you can help to ensure that your car's cooling system is working properly, and you can help to prevent overheating and engine damage. So that's it for today's video on car cooling systems. We hope you found it informative and helpful. If you have any questions or comments, please leave them in the section below. And if you